Hi, boys and girls. Today we're going to be doing section 5.4 for the second part, and we're actually going to start with example 4. Okay. In example 4, we're going to be proving a convection identity. So if you look at the example they gave us, we're going to prove that tangent of x minus pi is equal to just tangent of x. Okay. So for this, we're going to need our sum and difference formulas that we wrote in the index cards. So since we're going to be working with tangent and it's the difference, we're going to be using the bottom formula. Okay, so have your index card near so that you know which one I'm using. Okay, so since we're using the bottom one, I should have tangent of x minus tangent of pi over 1 plus tangent of x times tangent of pi. Okay. And now you can just use your unit circle to figure out what tangent of pi is. And according to our unit circle, tangent of pi is 0. Okay. So this is 0. Okay. So if tangent of pi is 0, then I can just simplify this to tangent of x, of course, minus 0, so I don't have to write that down. Okay. And then tangent of x times tangent of pi, but tangent of pi is 0, so this would be 0 times tangent of x, so that just cancels out. Or not cancels out, but it's just 0. So at the bottom, we have 1 plus 0, so I could just write it as 1. Okay. And then, of course, tangent of x over 1 should just be tangent of x. And then that's how we prove that the left-hand side matches the right-hand side, okay? So again, I just used the difference of tangents property, simplified it, and I got tangent of x, okay? All right, so before I give you one to try on your own, we're going to do one more example. Okay, so now we're moving on to example 5. Example 5 is just says deriving reduction formula. So we're just going to simplify each expression. So the first one we're going to work with is sine of 5 pi minus theta. Okay, so we're going to simplify this one. And of course, we're working with sine and we're working with the difference. So again, have your index card nearby. We're going to be working with this one. Okay. So here we go. According to the formula, I should end up with sine of 5 pi, and then should be cosine of theta minus cosine of 5 pi times sine of theta. Okay. Now, we can get a value from sine of 5 pi and cosine of 5 pi. So using your unit circle, 5 pi is basically 2 revolutions and then half a revolution. So it's basically the same as ending up as sine of pi. Okay, and same thing here. This is the same as cosine of pi. So it's 2.5 revolutions, okay? So if you look at your unit circle, sine of pi is basically 0. So this is the same as 0. So 0 times cosine pi is just 0, okay? And then cosine of pi, that is negative 1, okay? So negative 1 times sine of pi is negative sine pi, but then we have that minus there, so it's the same thing as doing this, okay? I'm sorry, I keep saying sine of pi, sine of theta. So, of course, a negative and a negative should equal a positive. So this would be the same as sine theta. And they just wanted us to simplify, okay? So sine of 5 pi minus theta is the same as sine theta. And that's it, okay? So the only thing I would say here is we use one of the properties, and remember that 5 pi, although you won't find it in your unit circle, is the same as saying 2.5 revolutions, okay? All right, awesome. One more example. Okay, for the next example, we're working with tangent. And so the directions are the same. So we have tangent of theta minus 3 pi over 5. I'm sorry, over 4. And so once again, we're going to be using this property, okay? So here we go. According to the property, we should have tangent of theta minus tangent of 3 pi over 4, okay? Over 1 plus tangent of theta times tangent of 3 pi over 4. So once again, we can get a value for 3 pi over 4. So let's find that one. So according to the unit circle, 3 pi over 4 is here. And then tangent of 3 pi over 4 is -1. Okay. So this is -1. Therefore, this is -1. Okay. That's what tangent of 3 pi over 4 is. So technically, what I'm going to have is tangent of theta minus, there's a minus there, and this is -1, so it'll look, oops, where's my eraser? So basically, it'll have like a double negative, which we'll simplify in a minute, but I'm just going to write it out. And then 1 plus tangent of theta times -1. Okay. So I'm just going to clean this up, but pretty much what it'll look like is now tangent of theta plus 1 because of your double negatives. And then your denominator would be 1 minus tangent of theta. And then since all they wanted us to do was simplify, there's nothing else I can do with this, or there's nothing further. That's about it. Okay. So with that said, I'm going to have you guys now try the checkpoints for example 4 and example 5.